In this example, we want to use calculators to see what happens to the behavior of the function. As x approaches a certain value, we're going to be exploring both left-sided and right-sided limits to see if the overall limit exists by using calculators and the tables that we populate using the calculator values. So now in the case of this function, when we're talking about the right-sided limit, notice it says limit of the function as x approaches 3 from the right. So we need to approach this value of 3 from the right side, from the higher values than 3. So for this reason, we want to populate a table of values. 3 values are usually sufficient to understand what's happening to the function. So we're talking about approaching from the higher values than 3 to the given target value of 3. So we're talking about starting from 3.1 and then 3.01, getting closer and closer to 3, as you can see, and even closer by having more zeros. 0, 0, 1. And now it remains to just plug in each of these x values into the given function to see what the function values are. So what I'm going to do, I'm going to plug in 3.1 plus 1 and divide it by 3.1 minus 3. What I'm getting in my calculator is 41 here. Now in the second case, I'm going to plug in 3.01 plus 1 and divide it by 3.01 minus 3, and I'm getting 401. And of course, logically, I should get probably 4001 because of the zeros here, and I can just test that. 3.001 plus 1 divided by 3.001 minus 3. Yep, 4001. So as you can see, what happens is we're getting infinitely huge as we get closer and closer to 3, the target value, from the right side of it, right? From the higher values of 3. So thus, we can safely say that the limit cannot be really determined. We can just write it as infinite, right? Infinity, positive infinity. Now, speaking of the left side, let's populate a list. And like I said, 3 values will be sufficient for that. And we need to approach from the left side now. So from the smaller values than 3, smaller values is going to be 2.9, 2.99, and even closer as 2.999, right? That will be the closest we can get to the value of 3. Now I'm going to use my calculator and I'm going to plug in 2.9 first. So 2.9 plus 1 divided by 2.9 minus 3, and I'm getting negative 39. So as you can see, the picture looks different already because it's negative versus a positive before. And then let's plug in 2.99 plus 1 divided by 2.99 minus 3, and I'm getting negative 399. And logically we should get negative 3,999 for the third example. Go ahead and check it if you want. But the tendency here is that here we see increasing. I'll write that a little better. So increasing here. But here we see decreasing values of the function. Right, so it tends to negative infinity here, right? Because it infinitely falls to really, really small numbers as we get closer and closer to 3 from the left side, right? For finding the left-sided limit. So the left-sided limit seems to be not found either, right? So it's going to be just negative infinity. Now notice when we were talking about does not exist, usually we write D and E whenever the limits that we found do not agree. Even when you cannot find the limit, even when it's infinity versus negative infinity, it's still not the same result. So whenever it's not the same result, we will just write does not exist. all right? Even though technically we didn't find any of these limits, right? Because infinity and negative infinity are not quantifiable. You cannot quantify what infinity is. We don't know what that's an infinite number. We don't know what it is. But still, even if infinity and negative infinity, they don't agree, so it does not exist. You have to be able to differentiate that result. Okay? So what I'm getting at, if they were both infinity, or if they were both negative infinity, we would not have written does not exist. We would have written infinity or negative infinity, depending on which two values they would both be. In this case, they don't agree. One is negative, the other one's positive. So it does not exist. You will see in the second case, it's not going to be the same picture. This is a different function now. We want to populate a list for both using the same values we've done before. The function values will be different because we're dealing with a different function. All right, 2.9, 2.99, 2.999. Okay, so let's see. I'm going to plug in 3.1 into this function, and let's see what I get. 1 minus 3.1 divided by 3.1 minus 3 being squared. And I'm getting negative 210. Now I'm going to plug in 3.1. 1 minus 3.01, I mean, divided by 3.01 minus 3 being squared. And I'm getting something really crazy, negative 20,100. And now, looks like we're adding zeros between 1 and adding a 0 after that. So it might be as well adding one more 0 or maybe two more zeros. I don't know. Let's check that. Probably one more 0 between the 0 and 1 here and 1 after. Let's check that to be sure. 1 minus 3.001 divided by 3.001 minus 3 being squared. I'm getting this. Negative 200. 1000. So like I said, yeah, we are adding this one more 0 and then one more 0 between this 0 and 1, so we get 2 now. Okay, good, beautiful. So I'm getting this result. So as you can see, this is decreasing to negative infinity here. Right? So we can say that this is tending to negative infinity, right? We cannot find the limit here. Now, so for the right-sided limit. For the left-sided limit, let's evaluate that and see what we get. 1 minus 2.9 divided by 2.9 minus 3 being squared. I'm getting negative 190. So this already looks promising. It might be that both of these right side and left sided limits tend to infinity, in which case the limit would be not DNE, but it would be whatever the result we get. But let's confirm that. So now 1 minus 2.99 over 2.99 minus 3 being squared, I'm getting, and by the way, I'm using TI-30XA calculator for this to find these values, negative 19,900. So it looks like we're adding, we're putting in 9 between the 9 and 0, and then one more 0 after. So we're probably going to add one more 9 between 9 and 0, and then add a 0 after. But let's check that. 1 minus 2.999 divided by 2.999 minus 3 being squared. Okay, so this is what I'm getting. 1,999,000. Negative 1,999,000. And like I said, yeah, we do add one more 9 and then one more 0 after. But in this case, you can see again that there's decrease there to negative infinity, right? It tends to negative infinity. Decrease. So there's decrease, so we can safely say that it's also negative infinity. Now notice the difference. In the first example, we had negative infinity and positive infinity. Here we both have negative infinity. So we cannot write does not exist, because even though we could not find both limits, they tend to the same direction, right? They both fall on both sides of the target value of 3 for the x. So the function tends on both sides of the x value of 3 in the same direction. It's going down on both sides of the target value. So we can safely say that the overall limit is negative infinity, tends to negative infinity. We can't say the limit is negative infinity, but the limit tends to negative infinity. It's infinitely falling. We don't know what it is, but we can't say it does not exist in the sense that we used before. So I hope this was helpful. Thanks for watching, and see you in the next video.